Alright, gang, with 3.3, we're going to be switching gears a little bit. It's actually probably going to seem like a major change of gears, but 3.1 and 3.2 definitely fit together nicely and made kind of like a package together. And so in 3.3, we're going to be talking about these things called polar coordinates. And I can sort of draw a connection to the past here with if you have a point in the plane, how do you describe where it's at? Okay. Now, you don't need to draw this necessarily, but just kind of like giving us a visual. If you have some point in the plane somewhere, how would you describe where that point is? And, for years now, you've probably described it by saying, well, we go left yay far, and then we go up yay far, and basically describe like an x coordinate and a y coordinate and like a set of those coordinates, But what if you had to describe exactly where that point was, and you weren't allowed to use words like x-axis or y-axis, and you certainly weren't allowed to use words like up, down, left, or right? How else could you describe exactly where that point is without essentially using x, y coordinates? Feel free to pause the video if you think you're up to the challenge and you think you can figure out a way if you don't already. So pause the video and then unpause it when you're ready. Well, another way to describe where this point is to talk about how far away from the origin it is. So you could talk about the length of that line, but you would also need to know where this line is, or like maybe what the angle of it was. You know what I mean? Think about it. If I told you the angle for like this, what's the angle of that? Like how many degrees from here to here, and then what is the radius from the origin to that point? Wouldn't those two coordinates, wouldn't those two values be enough to describe any point in this plane? Like how about this point? Right? If you knew the radius of this point as well as the exact angle to get all the way to here, that'd be enough. So essentially, gang, that's what polar coordinates is going to be. We have an r coordinate and a theta coordinate. And maybe we can just kind of add that to the... So r comma theta instead of x comma y. And so then in this first series of examples, we're supposed to plot the points that have the following polar coordinates. So where would the dot be that has a radius of 3 and an angle, a theta, of 315 degrees? So here's something you might want to write down. You should always start with theta, which means like figure out where the angle is first. And that's my advice. So, figuring out where is 315. Well, this would be 15, right? It goes 15, 30, 45, 60. I know these are radian measures on the outside of this little graph, but so we would go, let's see, that's 90, that's 270, 285, or sorry, 3, right? Yeah, 285, and then 300, then 315. So here's 315, right? And that is why we have all of these lines. See all the straight lines? I mean, I guess you'll notice right away, maybe I should have led with this and pointed this out first, but this doesn't look like your average XY plane, does it? That's because it's not. It's not technically an XY plane, it's a polar plane. And all of these straight lines are to help us plot the angle, and all of these circles are there to help us plot the radius, because this circle would represent the radius of 1, like you go out 1, like from wherever, right? From the middle, from the origin. So this circle would represent a radius of 1. This circle would represent a radius of 2. This third circle would represent a radius of 3, and so on. So this would be like 315 degrees, and then a radius of 3 would be right there. And so that's where you would plot the point of 3, 315 degrees. Okay, an R coordinate and a theta coordinate. All right, how about example B? Again, you should probably look at the angle first, which is pi radians, which is the same as 180 degrees, right? So we go all the way to here. So here's where we're at for pi radians, which is the same as 180 degrees. Now the radius is -2. Well, I mean, if the radius was +2, we would be here. Just like if the radius was +3, we'd be there. +4, +5. I think some quick logic might tell you that 4, 3, 2, 1, 0. And for -2, we'd actually have to go back to there. And that would be where you finish plotting the point for 180 degrees, but also a radius of -2 would actually go there. And if you're thinking now that, well, that's like the same as +2, 0 degrees, you'd be right. That's the same point. Okay? Let's do one more, right? Let's do example C, which was, let's see, we start with the angle, which is -pi/2. That's radians. So in degrees, that would be what? -90 degrees. Don't forget that a negative angle means you go this way, essentially clockwise. So -90 would be here. This is -90. And so this would be 1, 2, 3, 4, 5 for like a positive radius. But our radius, so here's our angle, and we need a radius of -1. So we got to actually go to there. And that would be a negative radius of, a radius of -1. And that's how plotting these points work. Now let's cover some relations between polar and rectangular coordinates. Real quick, polar, once again, just to kind of like, hammer this in, right? Polar means r, theta, and, This might be like a new revelation. X comma y can be referred to as rectangular. Like a rectangle. Think about it, it makes sense. So by rectangular we mean xy, and by polar, of course, we mean r and theta. Take a look at this handy dandy picture over here, where, if that was the point that we were plotting or finding coordinates of, the x coordinate would essentially be this length, right? X coordinate, y coordinate, yes? Right? So that would be like x and y, but then this would be theta, and this would be r. Essentially, time to state the obvious here. Like we have a triangle. We have a triangle. And having learned so much about, especially right triangles, like in Unit 1 in particular, we can come up with some relationships between r and theta and x and y. Namely, I'll just cut to the chase. The fact that if you do x squared plus y squared, you get r squared. This is the Pythagorean theorem, basically. This comes from, you remember, like way at the beginning of the semester, when we learned that the sine of theta was equal to y over r? You should. Sine of theta equals y over r. This is just saying the same thing. This is basically saying that. Just maybe like getting y by itself. So since sine of theta equals y over r, then it's just a very tiny leap from saying that to saying y equals r sine of theta. Likewise, it's a very, very, very small leap from saying that the cosine of theta equals x over r to saying this, that x equals r cosine theta. Okay? And the other connection worth writing down is that the tangent of theta would equal y over x. Okay? So those four mathematical statements, equations, whatever you want to call them, pretty much describe how the x, y values are related and connected to the r and theta values. And what we're going to do next is convert. And so these are polar coordinates, okay? And we want to change to rectangular coordinates. So this is like r, and that's like theta. And if we know that r equals 2 and theta equals 3 pi over 2, which is essentially, we probably prefer to say it as like 270 degrees. You should know how to convert that, namely plugging in 180 degrees for pi and just doing 3 times 180 divided by 2. 3 pi over 2 is the same as 270 degrees. So if we know what r is and what theta is, think about it. Which one or more, like one or two of these mathematical equations or formulas or whatever, knowing that r is what it is and theta is what it is, which of these can be used to figure out x and y? Well, these two basically. If you know r and theta, you'll be able to figure out what y equals, and you'll also be able to figure out what x equals. So here we go. We can say that x equals r cosine of theta. And so x is going to equal, let's see, r was 2. Theta is 270 degrees. Now you could feel free to check your cheat chart. What is the cosine of 270 degrees. That should say 0 on your chart. And so 2 times 0 is 0. So your x coordinate is going to be 0. And you could also figure out y equals the sine of theta. And so y would equal, oops, sorry, I knew something felt weird there, r sine of theta. Gosh darn it. So y is equal to r sine of theta, and so r is 2, and then theta is 270. And now we can just do this, right? So the sine of 270 is -1. And so overall, y equals -2, right? And so the overall coordinates here would be 0, -2. Those would be the rectangular coordinates. So plotting this point on an xy axis would get you the same point as plotting this point on a polar graph. Okay? Next example, just giving myself some more space here to work. You would do the same thing because we want to change this r and that theta to what it would mean as far as x and y. So same song and dance. X is going to equal r cosine of theta, and y is going to equal r times the sine of theta. And so now we have -8 times the cosine of pi over 3 radians, which is the same as 60 degrees. And y is going to equal -8 times the sine of 60 degrees. And you would check your chart, and I'm pretty sure that the cosine of 60 is 1/2. And I'm pretty sure that the sine of 60 is √3 over 2. Okay? And so that would be a final x value. What is -8 times 1/2? That should be -4. And when you multiply -8 times this fraction, there's some canceling, and essentially you should get that. And so your final coordinates together would be -4, -4 √3. Now going the other way, so what if you were given instead x and y, and you were supposed to find r and theta? So going back to here, I mean, I guess if you have like the powers of deductive reasoning here, we're going to use the other two. We're going to use this one and this one. Again, if what you are told is x and y, looks like this one would allow you to figure out r. And if you were given x and y, it looks like this formula right here, this little equation, would allow you to find theta. So here we go. Let's put that into action. Now, the first one is just merely the Pythagorean theorem. So x squared plus y squared equals r squared. And so we have 1 being plugged in for x, and we have -√3 being plugged in for y. And so 1 squared is easy, that's 1. When you square a -√3, the answer is going to be positive, first of all. And when you square a square root, they kind of cancel out, whatever. I mean, however your brain arrives at the ending here, when you square the square root of 3, you're going to get just 3. Okay? And so we get to here. And so the final move would be, take the square root of both sides. And, in a vacuum, you technically get plus or minus 2. But here, I mean, remember back from like Unit 1, the radius is always positive. So that would be my radius value. And then we use this. Don't forget that the tangent is equal to y over x, not the other way around. So we end up with the tangent of theta equals negative root 3 over 1, which is really just negative root 3. Now here's where you probably go to your cheat chart, right? And looking at your cheat chart, people, what do you find is like, what could theta be? So looking at your chart, when does the tangent of theta equal negative root 3? Well, that would be, that should be 120 degrees. But also, wouldn't that be 300 degrees? Are they both correct? Or just one of them? What do you think? Which one makes more sense? The fact that theta would be 120 degrees or 300 degrees? Well, I mean, think about what x was and what y was. X was positive 1. Y was negative root 3. What quadrant does that put you in? Doesn't that put you into quadrant 4? So, realizing that, doesn't that basically mean that we're probably looking at 300 degrees would be the angle that makes sense. So there we go. That means our coordinates for r comma theta are going to be 2 comma 300 degrees. And that's the final answer there. And I guess that was the only example there, huh? Well, moving on regardless to, okay, just kind of, now we're getting a little more heavy, I suppose. Now we're converting equations, not just coordinates, but equations. Well, the good news is we're still going to kind of use the same stuff, all this stuff in order to convert either x's and y's to r's and thetas or vice versa. So this equation has x's and y's in it. What are we going to do to kind of convert it instead to be in terms of r and theta? What do you think? What could we replace the x and or the y with so that it would now say just r's and thetas? Well, wasn't the x the same as r cosine of theta? And wasn't the y the same as r sine of theta? Yeah. So that quick switcherooski, see, now your equation is now polar. Because your equation just now has r and theta in it, not x and y. Okay, see what we did there? X is replaceable with r cosine, and y is replaceable with r sine. And in a way, you're done because this equation is now polar in nature, but good manners and good convention, means that we're going to solve this for r because we have good manners. So if we were to, how would we solve this for r? Well, the first thing we're going to do is factor out an r, like a GCF. Okay? And then what we're going to do is divide this bubble to the other side. I don't really have the room here, so I'm just going to kind of skip to the end here where we have that as the final version of our final answer. Okay? All right, so example B, let's see here. We have x squared plus the quantity y plus 1 squared equals 1. What do you think we're going to do? We have to change this equation to where, like, it doesn't have any more x's and y's. It just have r's and thetas. And, you know, like, I can think of a couple different ways to spin this, but let's just flat out do the same thing. Let's replace the x with our cosine, and let's switch the... Now, look, here's something I'm probably going to point out in class before I move on. What would happen next is that we would have to actually square this bubble, which is no big deal, but squaring this is essentially going to mean FOIL. FOIL, where you put, like, it's r sine plus 1 times like a repeat bubble of r sine plus 1, and that would require FOIL. It might actually be better business, like a better strategy, to FOIL this first. Like, resist the urge or just kind of hold off on replacing the x with r cosine and the y with r sine. And it might be better, I mean, I guess it would be up to you, but it might be better to FOIL this, you know, y plus 1 times y plus... You might find that easier, and then later you could replace the y with r sine, you know, any y's you have with r sine. But so squaring this bubble just ends up being like r squared and then cosine squared, but this bubble would be FOILed. All right, wow, holy moly. We're really taking some liberties here with these 3 dots. So maybe I will write up above here, when you were to FOIL, you would get r squared sine squared of theta plus r sine of theta plus r sine of theta plus 1 when you do firsts, outers, inners, lasts. So here's what I did to, like, get to here. You know, obviously this just became this. That's easy. This became this. But here was the result of the FOIL. And so here's the r squared sine squared right here. But these 2 terms just combine together to become this. So r sine of theta plus r sine of theta is just 2r sine of theta. But I also took this 1, subtracted it to the other side, and when you subtract it from this 1 on the other side, you got 0. So that's where all of this came from. Now, why did I feel the urge to, like, set it equal to 0? Because I want to now solve for r, you know, because I have good manners. So I can't just get r by itself. You know, the best I can do is factor... Ooh, wait a minute. Oh, man! I'm getting ahead of myself. Because here's what would happen. Man, this is juicy stuff. So just looking at those 2 terms, What if I factored out an r squared just from those two terms? Look what I have left over in the bubble. Cosine squared plus sine squared, which, do you remember what that equals? That's right, it's just 1. So what's r squared times 1? That's right, just r squared. So all of this just becomes r squared, and then this gets brought down to here. And now I'll just factor out an r as like a GCF. And what do you do after you set equal to 0 and after you factor? You set your factors equal to 0. So the GCF got set equal to 0. This bubble factor got set equal to 0. And that's where my red final answer came from. You know, when you solve this for r, you get that. So you get r equals 0, or r equals -2 sine of theta, which for now, I'll just say that the bestest final answer, not that there's anything wrong with this, again, I'll explain some other time. That is really the bestest final answer, just that. R equals -2 times the sine of theta. Whoa, that was a doozy. That was a doozy. So let's take a breath and just remember that when we're switching back and forth, so a little bit of a summary, I guess, as we take a breath. So we have r comma theta coordinates or x comma y coordinates, and these are the four, equations that allow us to jump back and forth between having an r and a theta values, and jumping back and forth between that and x and y values. And so we did a few examples where we took coordinates, r and theta coordinates, and we were able to switch those to be the equivalent xy coordinates. And we also did the other direction where we took xy coordinates, and using those equations, we were able to figure out what the corresponding r and theta coordinates were. And we took those same equations and we were able to kind of change a rectangular equation that contained x and y to being a polar equation. So really, you might be feeling a little overwhelmed right now, but it's probably mostly because of the cleanup, solving for r steps. Going from here, like once we replaced x with r cosine and the y with r sine, not being satisfied with that as an answer and going all the way until you had the equation solved for r. So again, look, right away we had something that was a polar equation. But when we proceeded to then, not call ourselves done until we had everything solved for r, man, what a can of worms that was, foiling this, this Pythagorean identity step, man, that involves some cleverness, let me tell you. So if you're feeling a little overwhelmed by that step, I don't blame you right now. It's a very clever little trick. But you get down to here where you're just trying to solve for r, You're trying to solve for r, and so this very clever move allows you to get to here, right? And that's where you go okay, I can't just get r by itself. So you do that whole setting equal to 0 and factoring and setting the factors equal to 0. And I guess if you look through this crazy problem a number of times, you'll get the hang of it. You'll be able to wrap your brain around eventually getting to here. But let's move on to the other direction, which is, what if we had a polar equation that we wanted to change into rectangular? Man, so how do we take an r and change it into x and or y? So look back at these gimmicks right here. If we know r, how can we, what could you replace r with? I guess you could replace it with y over the sine of theta, but that doesn't, we would still have a theta. Okay, looks like, same thing here. You couldn't just replace r with x over cosine of theta because you'd still have a theta. I mean, if we had an r squared, if only this was an r squared, we could replace it easily with x's and y's. So here's what we're going to do. We're going to square both sides. I mean, we're allowed to. And that opens up the door. That opens up the door to replacing the r squared with x squared plus y squared, and you're done. That's a fantastic place to stop, actually. Example B, how do we change something that's just theta in terms of x's and y's, or one or the other or both? And this is how we're going to do that. We're going to say, well, the tangent of theta equals y over x, and the equation says that theta is literally equal to 3 pi over 4. 3 pi over 4. What's that in degrees? I believe it's 135. Did I write? No, didn't actually write that in, but 3 pi over 4, that should be the same as 135 degrees. And if you look at your cheat chart, that'll tell you that the tangent of 135 degrees is -1. And now we're like a breath away, and what I'm going to ask you to do here is solve for y. And yeah, I don't know if you want to think of me as a hypocrite right now, but we didn't have to solve this guy for y, but I am going to insist that you solve that for y. It's easy. And so y would equal -x when you multiply x to the other side to get y all by itself, and now this one's done. Final stretch, I suppose. Example C. R equals -2 times the secant of theta. Well, here we go. I mean, what do you think we're going to do here? I don't think we want to square both sides. You know what I mean? I don't want to. I mean, what would I do with a secant squared? You know what I mean? I mean, I would have an r squared on the left, and that would be good. But you would have this would become +4, and you'd have a secant squared on the other. So yeah, I don't know if I want to go there. So what if I changed secant to what? What could you change secant of theta into? Perhaps you remember that secant of theta would be 1 over the cosine of theta. And what if you were to multiply the cosine of theta to the other side? Well, what you would get is r cosine of theta. didn't r cosine of theta like equal something? Heck yeah, that's just x. So, oh, just like that, we're done. We're done. That's it. So we were able to kind of work this into having like an r cosine of theta, which is just x. And that's like, that's the whole story. Now, compare that with example D. Man. Check this out. Again, I don't think it'd be a good idea to square both sides. Like, I know we would have an r squared on the left, and that would be a good thing, but we would have like 100 sine squared on the other side, and I don't know what we would do with that. So squaring both sides is not a horrible idea, but I don't think that would be the best way to go at all. So what happened over here? We were able to kind of, this became 1 over cosine, and we were able to get an r cosine, but it's already sine of theta. It's not like you could, like, you're not just going to get r sine. You know what I mean? Like, what are you going to do? Divide the sine of theta over there? Like, that's not going to make r sine of theta. That's going to make r over sine of theta. That's not good. So what the heck are we going to do here? I'll tell you what. We are going to not square both sides, but we are going to multiply both sides by r. We're going to multiply both sides by r. And if you think about it, that's genius. Because on the left side, we're going to have r squared. That's an easy switch with stuff that involve x and y. And over here, we're going to have an r sine of theta. And that also is switchable with something involving x and or y. So again, like, you tell me now, right? I'm not going to do all the heavy lifting here. Can you tell me what we can replace the r squared with? That involve x and y, not r and theta. R squared is x squared plus y squared. And what could we replace the r sine of theta with? That's right, y. So this 10 r sine of theta becomes 10 y. And now I'm going to pause for just a second to tell you that this is where I would be okay with you stopping. That would be a good place to stop, and I would give you full points on a quiz or a test. But if you want some bonus points, then I'll give you the opportunity to do that as I keep going here. Okay? Now let me quickly refer back to this final answer, which I was okay with because there is something called standard form of a circle. I'm assuming it's called standard form of a circle. And yes, a circle. If you were to graph this, it would be a circle. It just would. And this would be like the standard form of it, where h comma k would be like the center of the circle, and r would be what? You guessed it, the radius. So because this is technically in this form, I like this a lot. Your h value here is technically 0, and your y, or sorry, let me start that again. Here, technically your h value is 0, and your k value is also 0, and your r value is 4, but this is technically in circle form. This is not. Close, but no cigar. I want to eventually write it so that it kind of matches that form. Okay? Like I don't want to have a 10y over here. That doesn't fit the form. So the first thing I'm going to do... Oh, man. Let me move this for temporarily, okay? I'll bring those back in a minute, okay? But, so the first thing we're going to do is we're going to move this term to the other side. So it's y squared minus 10y. Now, the x squared is a-okay, right? You know what I mean? Like it's like x squared. Technically, this is like x minus 0 squared. But this, no. I don't want it to say y squared minus 10y. I want it to say y minus just some number, or plus some number for that matter, in a bubble that is squared. So this is where I group those together, at least in my mind. And here's where I do something called completing the square. Okay? Like, I'll go off on the side again here. If you think back to factoring and unfoiling, let's say I was, and I'll just, again, this is like just kind of just something for comparison. So you don't need to write this down necessarily, but what if I said m squared plus 8m plus 16. And I said, unfoil that. Wouldn't you have your bubbles be m plus 4, but then m plus 4 again? It's the same bubble twice. So couldn't you technically say that was m plus 4 squared? Yeah. That's what I want here. So I want to add something to this y squared minus 10y to make it into a trinomial that would unfoil to be the same two bubbles, like repeated. Let me say that again. What would be this magic final term? Y squared minus 10y plus what? To make it like a perfect square trinomial. A trinomial that when you were to unfoil it into two bubbles, it would be the same two bubbles repeated. What do you think? What would be this magic number? Pause the video if you want to and think about it. Well, the magic number here is 25. Y squared minus 10y plus 25 would make a perfect trinomial, okay? Now, quick teaching point here, but it's important. You can't just add 25 into there. But as long as you add 25 to both sides, you're good, you know? Like, you're allowed to add 25 to both sides. And so, what happens here? As a final answer is we get x squared And now that there's a 25 in there, it will unfoil into y minus 5 times y minus 5. In other words, y minus 5 squared. And I'm not sure what happened here. Should be a 25 there. So equals 25. And which now technically makes this into circle form. And if you're able to go to here by completing the square, that is going to be worth bonus points on the test. And that is what section 3.3 is all about.